everyone. Lovely crowd to see, and good to be talking in this edition of ElixirConf 2024. It's my first time, and hopefully of many more contributions in this event. So who am I? I'm Walid Salah. I'm a software developer at Evercam. I've been working with Evercam for now 3 years. We are a reality visualization platform that helps clients increase productivity through site visibility and team communication. So mainly using we have using cameras to capture live feed, so on and so forth, and other tools. I'm going to talk to you here in this presentation about my journey to create an open source project that we kindly named VR, a camera software that we aim for reliability and constant use on construction sites. So I'm going to start by describing basically what we do at Evercam. There's a certain code that we like to use to describe what we do. So basically, if you can see clearly and communicate with your teammate, then you can build a better pyramid. It was correct then, and it's still correct now. It's an ancient code that we like to use. This may include capturing drone images to display to our clients on the browser, reviewing their BIM. BIM means built-in information model, so basically a CAD or anything other than that, Revit, any other file, and a live feed on the browser, capturing the live feed. So speaking about that, one of the first challenges that faced us at the beginning is how to plan this. And we had some constraints due to our nature of being in construction sites. And the construction site had one of them constraints it. We had to be able to store resulting data for the entire duration of the construction site, the project. So a construction project can go sometimes for weeks, sometimes months, sometimes even years. So we had to reliably save recordings from a construction site for long periods of time. It had to be reliable and work under extreme conditions. So sometimes a camera is not doesn't have the luxury of being protected inside and everything. It has to be outside with rain, with heat, with everything. And also one of our basic needs that we needed in this project is it had to be easily debugged remotely, mainly because the cost of site visits is very much high. Because if we had, for example, our office is in Dublin and we had to debug a camera that is in Germany, somewhere else, it would cost us a lot just to get there and debug it. So we had to have the possibility to debug it remotely. So going from there, we had some of the constraints that we talked about. Also, the nature of the site, that the hardware that we're going to use. So we were constrained also by CPU, by power, by all means. So having that in mind, we conceived a typical setup for our camera, for our hardware next to the camera, which we appropriately called the box. I know, original. You can see here. There is some obvious things that you can see here in this image. Obvious, the power management. So for a construction site, sometimes power management has to be transformed from 220 volt into 12 volt, or batteries or solar. So one other thing is we had to have the ability to read those information, read the battery levels, so on and so forth. And also inside the box we have a router, a 4G router, we use it for our needs. So we don't have always the luxury of Ethernet or Wi-Fi. And the crown jewel of this box is we're using a Raspberry Pi, either Raspberry Pi or Jetson Nano. So since we prioritize long-term recording, we landed on a simple architecture. It was good at the beginning. We started as Nancy said, we started in 2015. We started with a simple architecture. The gist of the architecture is we have the cameras linked to the box, and the box is somewhere on the construction site, and we have what we call a camera server. Our first architecture is cameras connected to what we call the box, and connected to a server, not connected, a server on the cloud that is periodically fetching the recordings and the snapshots from the cameras, connecting directly to the box. So since this is a highly distributed system with sometimes 100 of images, we decided to go with the Elixir. We were the early adopters of Elixir and Phoenix into our ecosystem. And for that system worked for the longest time, but it has its downfall. We were only able to get snapshots, like big load of them with the cameras. After sometimes we lose connection to the camera, so we lose snapshots. Yeah. And also for clients who are a bit more sensitive toward data security and who want their assets to stay on the premises, we are now trying to support an edge architecture for an end-to-end solution, so that the data never leaves the site. So, next slide, please. So we decided to go on a new architecture, what we dubbed the edge architecture. So the gist of that new architecture is, as before, a camera connected to the box, but in this instance, the box is the one that is going to do the heavy lifting. So it is the one that's going to save the snapshots, save the recordings, and run AI models, maybe some light AI models, and record their events. And yeah, so next slide, please. With all that in mind, we started thinking about the software kind of things. So our first thought is why not reinvent the wheel? So we looked up already existing solution. Some popped up, like, for example, Shinobi, which are JavaScript solution, a Frigate, which is a Python solution, and NX which is built on top of C++. There's also a Moonfire, which is a Rust solution, but none of them were Elixir, and we love Elixir in this house. In any case, we would need to be a power user. So we needed a way to change the code to our specific needs. So the specific needs of our company. And because of this, we thought it's almost as easy to build our own software. So on the same time, have full control of the trade-off and remain on the Elixir word that we already are committed to. So next slide, please. There are also one of the reasons that made us move to that, to make that decision, is there seemed to be a lot of progress relevant in Elixir. So membrane popping up, nerves for embedded system into, in our case, the Raspberry Pi, so embedded systems. And for AI, huge developments in the Elixir and the AI world, mainly NX and Bumblebee. So next. So a passage that caught our attention in the book Elixir in Action is the comparison between two stacks of web development, one in Ruby, one in Erlang. And so in the Ruby world, if we wanted to go the Ruby world, for example, we would have had to rely on outside sources mainly. For example, if we wanted to embed our software, we would have to rely, for example, on Yocto. For streaming server, we would have to rely on GStreamer, and so on and so forth. But in the Erlang/Elixir world, everything was under the Elixir umbrella, and that helped us. That was something that was convenient for us. Right. So using Membrane, we thought of a solution to our problem, which is capturing images from a camera. So this graph is a simple one that explains how we do it. We start up at the top from an RTSP source. So every camera, the IP camera there is by default provides an RTSP stream that we can subscribe in and get the RTSP stream. So after that, we give it to what's called in the membrane video. It's like a hub that's gonna serve the video stream to multiple sources. These multiple sources in question are here, for example, is the storage system. So inside that box, we also have some storage solution that we save our snapshot, our recordings in it. And other than storage, we have an endpoint for WebRTC, so we serve WebRTC. And same thing goes for HLS. For HLS, we're serving the HLS stream. So following that plug-and-play architecture that we liked, we worked on other pipelines, you could say, in the membrane where they're called pipelines. And we plugged in a motion detection one. For example, we tried with using eVision and NX, try to get the stream decoded and get the stream and run a motion detection algorithm on it. As you can see right now here in this screen, you can see the in our Dublin office, the cars are moving and the red squares are somewhat following it. Yeah, so next one, please. So to represent how easy it was to implement this, so the call that was to add this was just added at the bottom of this pipeline. So if you can see at the top, we have our video T that is serving to the storage bin, and somewhat in the middle, it's also serving to the HLS and to WebRTC. And just at the bottom, we added a new pipeline that is gonna do our motion detection. So this motion detection, next one, please. This motion detection pipeline is just gonna run a simple Gaussian mixture-based background and foreground segmentation algorithm. It's an OpenCV algorithm already available in OpenCV and by extension in eVision. And yeah, so the algorithm is just simple. It has a history. For this example, we used a history of 10 images in the background, and each new frame we get in, we are applying it to this algorithm, and it's returning the changed the motion that has been detected in that exact frame. So next one, right. Right. So as we saw, it was pretty simple to implement motion detection with just plug in a pipeline. So applying the same principle, we experimented with using Bumblebee to run an AI model. So in this instance, we you used a simple AI model from Hugging Face. I know it's not very accurate. At the bottom, you can see sometimes it's a card and sometimes saying other rubbish, but this is it was just a prototype. And just to test if it is possible to run an AI model on the Pi live on a streamed camera. So after that, we are looking into use our AI model, our specific AI model for construction site, so with truck detection and everything. And the prospects look very promising in that. The next one, please. So other than that, that's a recent thing we added into it. We connected it to Livebook. So I'm sure all here are familiar with what Livebook is. And in this example, we implemented just a simple Livebook to debug our pipeline. So if we are debugging the storage pipeline in this instance, it would have been difficult to implement this feature traditionally, especially on the edge for production and production environment. Because we had Livebook integration already, we were able to create a storage pipeline monitoring prototype in 1 day only, and rather than like 1 to 2 weeks, 3 weeks to implement it, to deploy it on site and everything. This, along the AI model demos, show how easy it is to add blocks to our end-to-end system. So what's next for us? We would like the community to embrace this project, EXNVR. It's an open source project. We made it open source. It's on the link that you can see on the bottom, and with the QR code you can scan it, and it will take you to the GitHub repo. And next thing for us is we are looking into implementing, for example, the ability to use USB cameras instead of IP cameras. For now, also support more encoders. So for now, we just worked on supporting H.265, and H.265 is a little bit not adopted a lot in the industry, mainly with the browsers, mainly because we serve our clients on the browser, and H.265 is not widely supported on browsers. And also implement more computer vision applications. And so thanks everyone. So
thank you, Walid. I imagine giving a talk is challenging. Giving a talk remotely is even more challenging, and doing it during a power outage must be really hard to do. So kudos for your effort for still going through and giving this nice talk. So I'm looking if anybody has questions. You can use the Hua app to post your questions, and I'll keep an eye on it to see if you have any. And currently we don't. I think you mentioned actually basically everything. I wanted to ask what's next or how can people help, but you actually provided the link to the GitHub repository, and you even stated what the next things are for ElixirConf. Then I'm kind of wondering, what was the hardest thing to actually tackle? What was your biggest challenge in this project?
So mainly the video streaming, maybe working on Membrane, I would say, personally for me. And for the whole company, it was the hardware part of things. So monitoring the hardware, the hard drive, the CPU usage, the memory usage, all of that.
So the question is, how did you use OpenCV with Elixir?
So we use a library called eVision. It's a port of OpenCV into the Elixir world. It was like, it's a one-to-one, I would say it's a one-to-one implementation of OpenCV into the Elixir world. And really, the main thing that, like the main thing that we did before when we tried to run AI models from, not AI models, run OpenCV from the inside the Elixir was trying to call a Python function from inside Elixir. But since we discovered eVision, it was really easy not to go that route, just go for Elixir. And yeah.
Okay, cool. Thanks. And I think we're currently out of questions. Going once, going twice.
So,
okay. I want to thank you all for attending, and especially Walid for your effort for giving this talk. And I certainly hope that we'll see you next time as well at the next conference.
I hope so.
All right.
With
Thank you all.
hopefully not a power outage.
Yes, I hope so too. Yeah.
Thank you.